Hello everyone, this is Robert and this is the xTool MetalFab. It is a 1200 watt do everything fiber laser. You can cut metal, you can weld metal, you can clean off rust. In this video I'm going to be focusing on the cutting capability, and we're going to see if it can actually cut metal as good as it says, and if this thing is worth the hefty price tag. So if you're not familiar with the xTool MetalFab, you probably haven't been on social media much lately because they've been advertising very heavily. Basically, this is a 1200 watt laser welder and cutter and CNC machine. You can get this in various pieces. What I have here is pretty much everything. Down here is the 1200 watt welder, which you can also use for handheld cutting and rust removal. This is the CNC machine that the gun plugs into, so then you can do CNC cutting. And then behind it, I have the air compressor and air dryer, which allow you to do cutting on the CNC portion of this without additional gas, which is pretty cool. This whole package runs about $16,000. It's a lot of stuff, but it's also a lot of money, but it can also do a lot of different things. So my goals for this and future videos is to give you a better understanding of what's actually involved with having and using something like this, because cutting and welding metal is not as easy as what all of the little Instagram reels show. There's a lot of little things that you need to know, a lot of little accessories, and a lot of stuff to hook up. So let's go back in time and I'll show you what it takes to actually get all of this unboxed and set up. Before I get too far into this video, I did want to be transparent and say that xTool provided the MetalFab to me for free in exchange for making some content. There is no additional money being exchanged. They didn't pay me for any of these videos, and they have no editorial content over these videos other than factual corrections. But I have a long history working with them, and I've provided them with a lot of feedback on previous products, and even additionally with the MetalFab. I've given them a lot of changes and suggestions and documentations and features and things like that. So I'll kind of make note of those as I go throughout this video. But moving on, let's get to the unboxing. The entire shipment was 880 pounds, shipped freight, and it was separated in these two different pallets. The one that you see in the background, that's the CNC machine, and everything else was packaged on the other pallet. This includes the actual fiber laser, the air compressor, the air dryer, and the wire feeder, and a lot of the other accessories. The coolest thing about this whole system is xTool designed this to be unpackaged and set up by one person, no heavy lifting required. A lot of times when I get pallet shipments, it is really tricky to deal with them because it assumes that you have a pallet jack or at least an engine hoist or something like that. But this whole system can be done by one small human. It really doesn't require any lifting whatsoever to get all this stuff set up. This came with so many parts and accessories. I had so many boxes, so many nozzles, so many manuals. I have a big island in my workshop. It's 7 feet by 7 feet, and I had that thing completely full. And everything that you're seeing right here, this is not including anything from the CNC machine yet. That is a whole nother set of accessories. So be sure to dedicate some space in your shop for unboxing all of this stuff, and make sure that you have some space in a tool chest or some sort of storage to store all of the accessories in one spot, because you're going to need additional storage for all of this. The packaging on the CNC machine was actually really clever. For the crate, it had these little latches around the sides. You go around, you undo the latches, and the whole top lid kind of comes off, and then the remaining piece folds down like a ramp. Then you undo all the packaging on the actual machine itself, raise up the leveling feet, and then the whole thing basically just rolls out of the crate. If you've ever dealt with a pallet shipment with heavy equipment, it's usually just kind of bolted in there and you have to figure out a way to lift it up and out. But with this solution, it just wheels right out. I never had to lift anything. I have never had to struggle with anything. It was a really, really clever solution. Now, you might be thinking to yourself, that looks awfully short, and you'd be right. they have a really clever solution for this. It basically packs collapsed and it has an internal scissor mechanism to where you undo some straps on the inside, and it has a little crank that goes on the backside, and then you crank it up to its final height. I love this, and I also question the additional cost because it's a really nice mechanism, really robust, so it definitely added to the cost of it, but it definitely keeps the machine a lot more compact for shipping. So pros and cons, but it's really well done. There's just some metal pieces in the corners that you need to undo. Those kind of secure everything for fastening, and then once everything is loose, you go and crank it up to its final height. When you're cranking this up, there's a little white line on the outside of the scissor mechanism, and when that lines up parallel with the frame, you know that you've cranked it up tall enough. There are so many of these really cool little subtle details all throughout this machine. Now that the machine is at the proper height, it's just a matter of adding a lot of internal bracing and then all the side panels. In the earlier step where you removed those pieces before we ratchet it up, there's longer pieces that now go in those locations in the corner. They use the same screws, those bolt in, and there's also some diagonal pieces just to kind of increase the rigidity. This machine doesn't need to be all that rigid because there's no real cutting forces involved, but it does move relatively quickly, so just to keep it stable and not, shake all over the place, some extra rigidity is nice, and the machine is perfectly stable once it's all put together. I will say that throughout this whole process of unboxing and putting everything together, their documentation has been fantastic. Every single little thing came with a booklet that had instructions. If the instructions weren't thorough, they at least had a QR code that brought you to their knowledge base, and at least at the time I was filming this, the knowledge base was perfectly fleshed out. They had pictures and documents, and for most cases they had videos for everything. So they have a full video that is really well done on how to assemble this as well. And it's a much better video for assembly than I'm making here, but it does go over a lot of these details, and I ran into no issues. So I've got the CNC machine all put together, and it looks really nice. Everything went together just fine. Everything lined up, and yeah, it's really cool. I want to get this thing cutting by the end of today, but there's still a lot left to do. I'm going to need to mount the actual laser head inside here, route everything out. Probably going to need to go through and set the laser up. I haven't turned it on. I just need to turn it on, go through that setup. I also need to put something in the bottom in this tray. The laser is going to come down, go through the metal, and it just hits the bottom of the tray, and it will continue to go through. So they recommend like sand, gravel. They even recommended water, which I think is kind of weird, but something to stop that laser from going all the way through. So I've got to do that, and I also have to figure out something with the gas situation. You have to have some sort of gas or compressed air that goes through the nozzle when you're cutting. I'm going to go for compressed air right now. Thankfully, xTool also sent me their air compressor and dryer, which is specifically mated to this machine. You could also hook up an argon, nitrogen, or other gas into this as well. But I'm going to go with compressed air because it's not a consumable. I can just kind of generate that on site. So I'm going to get to it and do all the rest of that, and hopefully by the end of today, I can start cutting something with this. Powering on the laser for the first time was actually kind of interesting. It had your basic setup, asked your language, location, connect to the Wi-Fi network, all that good stuff. But it also made you scan a QR code. You had to load a web page on your phone, or whatever you scan the QR code with, and actually watch a safety video. And you couldn't really skip around. You had to watch the entirety of that safety video and understand all the safety precautions with the machine. And then after the video was done, it made you type in the serial number of the machine, and then it gave you a password, and you put that password into the laser unit, and that was the only way you can get past this setup to unlock the machine. And I actually think that's a fairly clever way of doing it, because a 1200 watt fiber laser is an instant eyeball deleter if you do not know what you're doing. There are a lot of safety precautions, so the fact that to unlock this machine, you must go through and watch and confirm their safety video, I don't know, I like that. I think it's a good idea. So this was the first piece of feedback that I provided for xTool. The printed manual mentions nothing about putting sand, gravel, or water in this bottom tray, but the online video and the online guide does. So if you're just following the print manual, you're going to miss this and you're going to have a bad time, and they're aware of this and they're going to make this correction. You need something in the bottom to stop the laser, as I talked about earlier. I went with gravel, and I'm glad I did because I think sand would create too much of an issue, and it's also kind of messy, and maybe the air of the exhaust would cause a problem. But this is just some rough gravel that I found at Lowe's. This was like $8 a bag. It's a half a cubic foot. One bag worked perfectly fine, but I ended up getting 2 bags, and I think 2 bags is probably better. So plan to get about 1 cubic foot worth of gravel for the bottom of this, and I'll try to remember to put a link down below for exactly what I used as a reference. So I've run into my first issue, and it's power. Here I've got their compressor. This is the air dryer. This is the actual laser welder, and then of course over here is the CNC. This has a 110, CNC has a 110. It's really only like 2.5 amps, not a big deal. And then the welder has a 50 amp, and the compressor has a 50 amp. Looking at the manual, these don't need to be 50 amp, and they probably shouldn't come with 50 amp. The laser welder itself is only rated at like 25 amps at 220, and they actually recommend an L630R, which is a 30 amp twist lock. And then for the compressor, all of the pictures show it with a standard like 20 amp plug, not a 50 amp. So I'm gonna have to swap these out because who has 2 open 50 amp receptacles? So I'm gonna swap those out and we can get this all plugged in and running. Okay, so I finally got everything powered on, and I'm at a point to where I'm going to be going through the calibration. The thing that I learned is everything has to be fully on before it will let you really do anything. So the laser itself needs to be hooked up to air and have an appropriate amount of air going into it. That needs to be connected to the machine. Everything needs to be in its happiest state. This is really messy, but back here, I've got the air compressor and the air dryer. So the compressor goes into the dryer, and then that goes out to the laser. And this would be the setup that you would have if you were running it like this. So there's a lot of stuff. There's a lot of stuff to run. If you were running off of gas, you wouldn't need the compressor. You might still want the dryer cleaner, but you wouldn't need the compressor for compressed air. You would just have a tank of gas. So yeah, I'm gonna go through the calibration. We'll get this thing hopefully ready to cut. Although I do have footage of the full calibration process, it was pretty uninteresting and I didn't run into any issues, so I'll just kind of summarize it here. The machine wants to see that the laser is going down through the center of the tube and it's aligned with the cameras. All of that was fine for me, so I just kind of clicked next. And then the rest of it is basically what you would run through when you have like a new modern 3D printer. It does the vibration compensation and a few other things, so you're just kind of waiting for it to finish, and there's just a little wizard that you clicked next through. But I didn't run into any issues. There was a lot of QR codes through the whole process if you did. So now that this thing's all calibrated, let's cut something. Okay, so I think I have everything set up. I've got the calibration done. I've got some gravel in the bottom. I've got the air hooked up. I think it's a little bit too high a PSI, but we'll figure it out later. And I have one of these pieces of stainless steel loaded in. They have kind of a little sample thing that kind of runs you through the tutorial, so I've got that loaded. The only thing left to do before I hit go is to peel off this protective film so I can actually see inside the thing. So this is my very first time cutting metal with a fiber laser, and even though I've seen this online, in person it was awesome and I'm absolutely hooked. In the future I am going to do a better job filming this because I don't want it to look like I'm just lasering myself in the crotch. I'll figure out a way to deal with the reflection. But as I said earlier, this is just kind of the tutorial or the demo that is loaded with the program. So when you just load it up for the first time, it kind of guides you through everything and explains why you're clicking on certain things and what to do next. And yeah, it all went perfectly fine. The edges are crisp, and I am really, really impressed so far. The noise you just heard in the background was me opening the garage door because I forgot to connect the exhaust hose. Out of all of the things that were on my little checklist, I forgot the exhaust. For future, I'll have this exhausting out the window instead. But right now it was just kind of exhausting into the room, and that is not a good idea. So here is the first little demo project, and it came out really nice. I think you're supposed to weld it together. I just kind of have it taped together for right now. Let's take a closer look at the edge quality. It's pretty darn good. It looks a lot like, laser cut. It's not as nice as a water jet cut, but it looks very, very nice. This is 1mm stainless. The hole is really nice up there. You can't really see where the pierce was. Nice edges. Same with this piece. All the little details in the claws. These are very sharp. That one is very, very, very small. And I couldn't really tell visually what is the front side and the back side. You can tell a little bit by feel. Like I can feel that that's the back side, and there's maybe a little bit of discoloration here and there, but generally speaking, this looks very, very nice, and you'd have no need for gas. The compressed air works perfectly fine. Let's try something a little bit more complicated. This is a file that my friend James sent me. He just wanted to kind of see the machine in action, so he sent me this file to test. I'm not sure where it came from. I made a little modification to add an eyelet on the top so I could use it as a Christmas ornament. And this is all real time that you're seeing. The total cutting time for this was just under 2 minutes. The software predicted about 1:40, but it was closer to about 2 minutes. So here is the finished ornament. When my friend James actually sent me this file and he's like, this is the first thing I want to test, I thought that that was just kind of hard mode and it was going to be really difficult, but it did a great job. This is the front side and that is the back side. No post-processing. I didn't do any sanding, no deburring. This is straight off of the machine. And as you can see, there's no dross. My fingernail really doesn't get hung up on anything. There's really no edge on the backside, just a little bit of light sanding, and this will be good to go. I did have to poke out some of these little pieces. They kind of get stuck, but this is the type of thing that was falling out from it. Very thin, weird shapes. This isn't just going to fall out naturally on its own, but to give you an idea how fine this stuff can be, that is how thin the edge on some of these tapers ended up being. Very, very fine. So I'm pretty impressed with this. There's just a couple little like burn marks here and there, and these just kind of rub and or sand off. So yeah, shouldn't be an issue. So let's talk about some other materials, but to do that, we need to talk about nozzles. So here are some of the nozzles and attachments for the actual laser head. This is the one that you would use for standard welding. You can see there's a little slit at the bottom for the wire to come through. This one is for handheld cutting. And then this one over here is what attaches on the CNC machine. It has some little pogo pins right there, and it has this nice adjustment. For all of these, they are just straight through tubes. There are no optics or any glass inside of these. No focusing is being done by these other than just by the actual physical height of the mechanism. For the CNC cutter, you have an assortment of different nozzles to use. This is the one that I've been using up until now, what you've seen on the video. This is just a straight through nozzle, nothing really more to it. This gets really close to the workpiece, pierces through. This is good for fine detail stuff like what we were doing. If you're going to be doing thicker cutting, you might need to switch over to this save gas nozzle. This has a little telescoping ceramic piece. You can see what it looks like when it gets kind of worn and used a little bit. It has this little ceramic piece that rides on the top of the material, giving you a better seal. It basically presses down and gives you a seal against the top and lets the gas do a better job actually penetrating through the cut. If you were to use something like this on this design, it would get hung up on all these little edges and cause a problem. Ask me how I know. So that's more used for thicker cutting. xTool claims that when you get beyond about 2 millimeters or 3 millimeters, you need to go to more of a cutting nozzle because this one just really won't cut it. For thicker materials, they have this one, which is an extension tube, and it has some sort of airflow pattern inside. I forgot exactly what they call this. I'll have that up on the screen. I haven't used this one yet. I haven't cut anything thick with it, but when you start getting to this guy, you should probably start using gas. The compressed air, they claim that over, I think, like 2 or 3 millimeters is the limit of what you can do with compressed air. Let's test that limit. So this is 3 millimeter or 1/8 inch thick 6061 aluminum. That is what the edge looks like. This was 50 millimeters by 25. Looks pretty good. Can you guess which one's the top and which one's the bottom? Probably on camera you might not be able to tell. I think, yeah, this is the bottom. There is a little bit of a lip, really hard to see, but that's the amount of dross that's on 3 millimeter aluminum. Measurements, about 49.8, 49.9, and 25, and about 24.8. There is a kerf offset in the software, so you can dial this in, but that's pretty much all I could ask for. Looks really, really nice. That is the lead-in cut, it looks like. The edge feels fine. There's not like a lip or anything. It's also not tapered in any way. You can see it is perfectly square, and just a little, not on that side, just a little bit of a lip. Let's go thicker. I could probably do an hour-long video just on all the little clever touches on this machine, but it's too much to talk about all at once. Just the little sliding clamping mechanism on the side, the stainless steel way covers, the way that the hose is actually routed through and attaches to the machine. There's so many really cool quality of life details on this thing. So as I suspected, 6 millimeters is at the limit of what you can do with compressed air, at least for aluminum. I tried a couple different things. Here you could see I did a longer lead in because I saw that with the circle it just really wasn't piercing through, and then eventually it did pierce through, and that's a pretty clean cut. And then up here, I think a lot of it had to do with the compressor. It wasn't initially kicked on. Once the compressor kicked on, then it was able to offer the airflow that it needed. But yeah, I mean, this is at the limit, and it's, yeah, pretty nasty on the backside. But this is to be expected. They say only up to about 2 millimeters. I was able to do 3 millimeters, no problem. 6 is just outside the question. So for something like this, you need to use, I think, what, oxygen or nitrogen. I can't remember what you use with aluminum. I'm gonna get my bandsaw and actually cut this out so we can see what these clean sections actually look like, because they do go all the way through and look relatively clean. So here's what it looks like when it's cut free. As you can see, it was definitely struggling on the first part of the circle. The back side of the circle looks pretty bad all over, and it never really did the clean cut. But once it got to the actual square, it did a decent job. Like, let's see, that edge looks all right. That one looks all right, and dimensionally, when it cut appropriately, yeah, it's about where it should be, about 0.2 under. So yeah, 6 millimeters is absolutely outside of what you can do with just the air compressor. I think if you had a little bit more air pressure, you could probably get this done with a little bit of the settings tweaks, but the manual even states that this is way outside of what it can do, and I confirm. Just one more little thing before I wrap this up. This is the 3 millimeter piece that was cut out, and if I line this up, you can see just how small the kerf is on a fiber laser. That is the total amount of movement that you have, just a little bit, but it almost fits perfectly in there. It's kind of cool. Wrapping up this video is going to be really challenging because there is so much still to talk about for this machine, and I haven't even talked about the welder. I haven't even really talked about the air compressor or the air dryer. There's just a lot to this system, and it's a little bit overwhelming for me as like a content creator, but as someone that is actually using it, it is all pretty straightforward. It worked exactly how I thought and how I expected it would work, but there's so many features I'm not even talking about. The auto nesting, so you have a piece of material that you've already cut a bunch of stuff out and you want to cut more stuff, you can click a button and it will automatically arrange it in all the unused spaces. The fact that it has one camera there, one camera in the main machine. It can even do like tracking on the material. So if you have material that's slanted, or think of like, corrugated steel sheeting, it can actually follow the contour of that. That's pretty amazing. There's just a lot that I'm not yet covering. And also when I get a proper gas cylinder, or maybe a couple different gas cylinders, that will open up much thicker cutting performance. So then I can switch over to that double layer telescoping nozzle and we can start, seeing how thick this can cut. But what I can say is that this has met or exceeded all of my expectations. I expected there to be a little bit of hurdles here and there, and it works exactly like my CO2 or my F1 Ultra little mini fiber laser. You just load it up in the exact same software, select your materials, select the parameters, and you're good to go. If you're an absolute beginner that wants to do this, for like crafts or things that you're going to be selling on Etsy, this is a great example of that. I really wouldn't be that intimidated by this machine. You can, as a single person, unbox it yourself, get it set up yourself, and start cutting. I really didn't have any failures other than what I just showed with the 6 millimeter, but that's clearly not recommended and not a use case that you should be doing with just the compressed air. The only downside that I really see is their materials library is very expansive, but it's missing a lot of common stuff like 1/8 inch carbon steel. Like you would just go to Home Depot or Lowe's and just get 1/8 inch steel. That wasn't in there. They had like 19 gauge steel, which isn't a thing. So they're definitely missing some different materials. I fully expect them to kind of build that out a little bit more. The materials library is also very difficult to search. I submitted this feedback with xTool. I've seen the other competitors' software, and you basically have to guess on all the feeds and speeds and know what the different frequencies are, and you have to do a lot of trial and error. With this, you can basically just start, like with the mild steel. I just started with one of the steel profiles. It was a little bit thinner, so I slowed it down, and that worked out just fine. So it's a pretty easy machine to just kind of get set up and get cutting in one weekend. I'm happy with it. I'm going to be doing a lot of stuff with it. The price. This is an expensive piece of kit, but it's also a highly refined and finely tuned tool. There are so many little aspects about this where you can see extra cost. The way this nozzle attaches into the machine, the fact that it has the pogo pins for the capacitive touch in there, stainless steel way covers, kind of has a little roller mechanism inside there. Some of the competitors just use kind of the normal cloth accordion, which is going to get messed up. This is going to be a lot more durable over time. There's a lot of quality of life and high quality fit and finish in this machine that you don't really see in a lot of the others. Some of the other competitors don't even have the camera on there, so you just kind of have to do the old school like laser box trace if you want to start positioning stuff. I'm very, very pleased with this. I think it's worth the price. I also have somewhere around here an Laser Lab welder, and I'm going to be kind of comparing these two. It is a lot cheaper, but it also doesn't have as many features or quality of life benefits that the xTool has. So I think the price is proportionate and reasonable for what you're getting, but there are absolutely cheaper options out there, but you don't really get the same thing. So comparing apples to apples, I think the price is reasonable, but if you're comparing apples to oranges, there are cheaper options out there, but you just miss some of those features. So that's my 2 cents. I'm going to be using the hell out of this thing. I am really, 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 really happy to have this in my shop. It's a completely different thing that I didn't have before. So yeah, you're going to see this show up in a lot of videos. Thanks for watching. Leave any comments down below. If you want to see more things about this, just let me know. I'm going to be making more videos. Thanks for watching. See you in the next video.